Hello students, this video will more in-depth focus on boiling. As a result of this video, you will be able to specifically define and explain boiling point, be able to explain why different liquids have different boiling points, and know the relationship that atmospheric pressure and vapor pressure play with boiling, and how with varying atmospheric pressure you can actually determine the boiling point of your liquid. So let's dig in. Let's remind ourselves of the difference between the two specific types of vaporization. Evaporation is vaporization just at the surface, where boiling is throughout. A lot of students believe that the difference between boiling and evaporation is that boiling requires the input of heat energy. But we need to correct that. Boiling point is actually the temperature at which the equilibrium vapor pressure of a liquid equals atmospheric pressure. Let's explain this further. You know that water at room temperature does not boil under normal conditions. So, if we have a beaker of water, well, we know that there's atmospheric pressure above it. And if we're at sea level, we know that that is equivalent, we could just approximate, to be 1 atmosphere or 760 millimeters of mercury, 760 torr. So that's a pretty big pressure. Well, we know that water, in being a liquid, is hitting into each other, and some is creating some vapor. But that is minimal at 25 degrees Celsius. Vapor pressure at 25 degrees Celsius of water is 23.8 millimeters of mercury. It is minuscule in its size of force compared to atmospheric pressure. So, according to this definition, we are not boiling at 25 degrees Celsius because the vapor pressure of the water is not equal to the vapor pressure of the atmosphere. Well, how can we get these to be equal? We talked about the relationship of temperature and vapor pressure. It is in all ways that as we increase temperature, vapor pressure increases. So what if we do add heat? Then this vapor pressure begins increasing because we're giving more energy to the liquid to create vapor, and more vapor pressure. So as we're adding heat, we're increasing this more and more and more. So it is creeping up and getting closer and closer and closer and closer and closer. And it just so happens that at 100 degrees Celsius, the vapor pressure of water is 760 millimeters of mercury. So when these two things are equal, we are at the boiling point of the water. Now, can I be honest with you that as a student, this just so confused me? Because it seems like, wait, if we're trying to get a greater pressure upon the water by its own vapor to equal atmospheric pressure, isn't there just more pressure pushing down on the liquid? How is that, allowing for boiling? But what we have to allow ourselves to see is that vapor pressure is somewhat a reflection of the energy of the liquid. So as we are giving more and more and more and more energy to the liquid, then vapor pressure is becoming more and more or less and less of an obstacle for vaporization throughout the liquid. So as we're adding, we're getting these to be equal so the energetics of the liquid can overcome this vapor pressure. The atmospheric pressure of that